Exercise 1.2, binomial expansions. It sounds pretty complicated, but it's really simple. So binomial expressions, so they're just expressions that have two terms in it. So for example, x plus 4, there's two terms. Or x squared take away 5, again, two terms. Two linear binomial expressions, so linear just means x to the power of 1, can be expanded to create a quadratic trinomial. So quadratic just means x to the power of 2 and trinomial, 3 terms. So as an example, x plus 5 multiplied by x plus 3, it's x times x, which is x squared, x times 3, which will give us 3x, 5 times x, which is 5x, and 5 times 3, which is 15. I have two x terms, so I add those together, and now it ends up having x squared plus 8x plus 15. So that there is a quadratic trinomial. Quadratic, and then the trinomial part, 3 terms. Whenever we're doing expansions, then you're going to make use of FOIL, which is just a process I explained before. So there's an expansion of it. The positive perfect square rule, so if I have a plus b all squared, then it's a squared plus 2 lots of ab plus b squared. The negative version of the perfect square rule, so if it's a minus b all squared, then it's a squared minus 2 lots of ab plus b squared. And then the difference of two squares. So a plus b multiplied by a minus b will be a squared take away b squared. The top one and the bottom one are essential that you know how to do that really efficiently. Alright, so expanding the following. First one for a, 2x times x is 2x squared, 2x times negative 2, negative 4x, 3 times x is positive 3x, and 3 times negative 2 is negative 6. Collecting like terms gives us that. B, I've got 3 factors listed. I always expand out the brackets first, so I'm going to leave the x there. 2x times x, 2x squared, 2x times negative 1, negative 2x, 3 times x is positive 3x, and 3 times negative 1 is negative 3. Collecting like terms, then multiplying the x3. B, I've got 3 linear factors there. I'm just going to leave the first bracket there. You can see the expansion of the last 2 brackets. Collect like terms. And now I multiply the x through each of these terms. So x times 2x squared, x times 13x, x times 15. And now I take the 4 through, so 4 times 2x squared, 4 times 13x, and 4 times 15. Collecting like terms, so there's only one term involving the 2x cubed. I've got 13x squared and 8x squared. I've got 15x and 52x, and then just the 60. D, positive version of the perfect square rule, so x plus 3. So it's x squared plus 2 lots of the x times it by the 3 plus the 3 squared. And it ends up being this. Of course, you could apply FOIL to that too. The negative version, 3x minus 5 all squared. So I take the 3x and I square it, not just the x, but the 3x and square it, minus 2 lots of the 3x times 5 plus 5 squared. It becomes that. And for f, I've got 5x plus 6 multiplied by 5x minus 6. So here we're going to apply the difference of 2 squares. So I see this as being the a and the 6 as being the b. So it's going to be the a squared minus the b squared. So 5x squared minus 6 squared. 5x squared is 25x squared and 6 squared is 36. We can also make use of our CAS. So you can see the expansion here of x plus 2 cubed and x plus 3 to the power of 5. So just to show you what that looks like. Menu, algebra, and expand. And I want to expand the bracket x plus 2 to the power of 3. Hit enter, and there's the expansion of it as what's shown here. And I don't need to show you how to do B.